So hi and hello there. Welcome to the new video of the course. So till now we had seen different basic topics based on digital electronics, like what are logic gates. Then we simulated different logic gates on Proteus and Tinkercad software, right? Then we also saw the minimization techniques. We solved certain numericals based on it. Then at the end we saw universal logic gates, okay, and lots of stuff we had done till now, right? So I hope by now you might have got a clear cut idea about the digital electronics, right? So till now we had covered the theoretical aspect, or we had gained theoretical knowledge of all of these things, okay? But now we are going to deal with one project wherein we are going to use certain concepts that we had studied till now, and we are designing one project, and the name of the project is water overflow controlling system. So basically our agenda in this particular video is to control the overflow of the water, okay? So for that, let's dive in the project, okay? And this is the block diagram of the project. But before coming to this particular block diagram, let me just draw this. So let's assume this is a tap. From this particular tap, water is flowing, okay? Water is coming out of this particular tap, okay? And this particular water is getting stored in the tank one. So let's assume this is my tank one, and whatever the water that is coming out of this particular tap, it is getting stored in this particular tank one crate, okay? And you know, let's assume we don't have any controlling system, so the water may get filled till this particular point, okay, up till its brim of the tank. And once if it gets filled up till this point, so the next step would be, or the next level would be, the water will get overflow, or the overflow of the water may start from the tank one. So to avoid this particular scenario, we had designed a system wherein what we are doing, we are actually putting the sensing element in this particular tank one, okay? And the output of this particular sensing element would be fed to the controlling block, and depending upon the output of controlling block, the water pump will operate, okay? So if controlling block will give the instruction to water pump that, okay, now suck the water from the tank 1 and fill it to tank 2, okay? So let's assume this is my tank 2, this is my tank 2. So to avoid this overflow, what we are doing, we are actually using two tanks, okay? So whatever the water, okay, whatever the extra extra amount of water that is coming in tank 1, that is getting filled in tank 2, okay? So with this particular process, what we are doing, we are actually saving the water, okay, or we are actually avoiding the wastage of water. So this is the main agenda of this particular video, okay? So I hope you got a brief idea that what exactly the project is all about, but still I'll just explain it to you once again. So this is our sensing element. This sensing element will actually judge the water level, okay, and depending upon the water level, it will give the output to the controlling block, okay? And now since the controlling block is getting certain input, okay, depending upon the water level, so it will give the output depending upon the input. And so the output given by the controlling block will act as input to the water pump, and depending upon the input of the controlling block, the water level of the tank 1 will get adjusted. Or in short, what I can say is that the extra water or the extra amount of water that is present in tank 1, it will get sucked and will get filled in tank 2, okay? So this is the basic idea of this particular project. Great. So now we will move further. All right, so now what we are going to do, we would be just focusing on the sensing element, okay? We would be just focusing on the sensing element, okay? As such, we are not using any sensor, okay? Basically we are building our own sensor. I mean, we are not as such building our own sensor in real sense, but just with the help of certain logic, we can build our project. But before that, let me tell you that this particular project won't be that efficient. I will tell you the reason after some time. This particular project won't be that efficient, okay? But still, why we are doing this, so that your logic would be developed, okay? Your logic would be developed, and most importantly, you would be in this situation to understand the practical aspect of the electronics, okay? Practical aspect of the digital electronics, to be precise, or the concepts that we had studied till now in this particular course, okay? So obviously this is your water, okay? And what we are doing, we are actually putting two wires. So this particular wire, okay, it is present at the base level of the tank, Okay, so this is your tank 1. Let me just write over here. This is my tank 1. This is my tank 1. Okay, so we have two wires or two jumpers. You can also say jumpers or wires. Okay, so the first wire, it is inserted at the ground level of this particular tank. Okay, so it is present at the bottom of tank 1. Okay, so this particular wire is present at the bottom of tank 1, and the second wire depends on the your desired your desired water level, I mean your desired level. So if you want that I need to connect this particular wire at this point, so you can also connect it over here. If you want that no if like the water level should be filled till this point, and once if get exceeds over this point, so this particular pipe or the water pump which was present over here, it should suck the water. Okay, so it's up to you. You can place this particular wire anywhere. If you want, you can place over here. If you want, you can place over here, over here, over here, over here, over here, over here. But make sure you don't place over here, because you know if this particular controlling block gives some delay, okay, so there might be high amount of chance that the water may get overflow, and then this particular water pump will suck the water. So you know we won't be able to manage all these things, right? So make sure this would be your last point. Okay, surely you should not exceed above this particular point. Okay, any which ways, the whole of the idea is that we have two wires. So the first wire is placed at the bottom of tank 1, and the second wire is, let's assume, it is placed over here. Great. Okay, and the pH level of the water is 7, right? So let me write over here, the pH of the water is, the pH level of the water is, pH level, sorry, not level, pH of water or H2O is 7.0 or 7 in general, 7. So it is neutral, right? It is, sorry, it is neutral. So it indicates that the water is neutral. It indicates that water is neutral. Okay, and if you could remember the, you know, if, in the course 1, or maybe if you have a just a basic idea about electricity or current electricity, so current does not pass through the pure water. Current doesn't flow through the pure water, does not flow through pure water. So that means what? We need to add certain impurities to shift this pH. Okay, to shift the pH level of the water. Okay, so let's assume we are adding few certain amount of salt. Okay, so we are adding salt. So by adding salt, okay, just a small amount of salt will do. Okay, just by adding salt we can change the pH of H2O. Okay, pH of H2O, and then the water, then this water or H2O will conduct current through it, or will conduct electricity in general, will conduct, then this water will conduct electricity. So this is our basic idea. So if this particular water, if it is present in its pure form, or if it is neutral, or if the pH of the water is 7, okay, so we cannot do anything, or our system cannot work if this particular water is if this particular water has pH level of 7. So that's the big drawback. Okay, before starting the project only I told you the drawback, and that's why I told you in the, if you could remember, that this particular system, it is not that efficient. So in real life we won't be using it, but just for your understanding purpose, or just to develop that logic, okay, that engineering kind of mindset, I'm taking this project. Okay, but my main agenda over here was to design this controlling block. Okay, because see, anyway ways we are student of electronic engineers, we are student of electronics, right? So you don't need to worry about this chemistries and all, but still, okay, like if let's suppose if you know you are working in some different system, so there might be possibility that whatever the content, maybe let's suppose if you are working in some chemical industry, So there might be possibility that the instead of water there might be some chemical, and if you want to control the level of chemical, so if that chemical is quite acidic in nature, so there might be possibility that it might conduct some current. But again, lots of things needs to be considered, that whatever the current that we would be passing through this particular water, it shouldn't be, it shouldn't harm that particular chemicals and all, and which ways, that's different scenario. Okay, that's totally different scenario. But what we can do over here is, now see, let's assume that you are taking one battery. Okay, we are taking one battery. So this is your battery. Okay, this is grounded. This is the positive terminal of the battery. It is inserted in the water. Okay, it is inserted in the water. Okay, so now let me just add one more slide over here. Okay, this, and okay, and let me take the two cases. So let's assume this is your tank 1, and these are the 2 points wherein we had kept the wires. Okay, these are the 2 tanks we had kept the wire. Okay, so this is the point, or the bottom point, where the wire 1 is present. Let me change the color. Okay, so over here your wire 1 is present, and over here, somewhere over here, your wire 2 is present, right? So let me just show it with the help of the green. This one with the green. And as I just told to you, now we had inserted the positive supply of the battery in the water itself. So the positive terminal of the battery, it is also inserted in the tank 1. So this is my tank 1. Okay, and the positive terminal of the battery, it is inserted in the tank. Okay, it is also inserted in the tank, and the negative, it is negative 1, it is grounded. Okay, so this is plus minus VCC. Great. And now let's assume that there isn't any water in the tank. Okay, let's assume there isn't any water in the tank. So if there isn't any water, so this particular 2 wires will act as a open circuit. So these 2 wires will act as a open circuit. See, this 2 wire, it will act as a open circuit. Great. And now we will take the second case, wherein, again, let me just draw the tank. So this is that tank. Okay, let me just write over here, this is my tank 1 only, tank 1. Okay, and let's assume those 2 wires. So this is wire 1. Okay, and this is wire 2, placed at this particular point. Okay, so just a second, let me draw each and everything perfectly, so that there shouldn't be any doubt in your mind. These are the 2 wires, and this is your battery. The positive terminal, the negative terminal is anyhow grounded, and the positive terminal, it is given in the tank. Okay, so this is plus minus of VCC. Great. All right, so now let's assume over here the tap was closed. Okay, what is the tap? As I told you, just a second, let me bring it little down. And let me show that the tap over here. So let's assume this is that tap. Okay, let's assume this is that tap. Okay, and the tap is closed. Okay, tap is closed, so water won't flow. Therefore water won't be flowing, or won't flow. Okay, but now let's assume this is another tank. Tank 1 only, but now the case 2 is, let's assume the tap which I'm drawing over here. Okay, which I'm drawing over here, it is open. The tap is open. Therefore water will flow. So whatever the water that is coming in the tap, it will flow, and it will be getting stored in tank 1. So let's assume the water is coming over here. Okay, it may get filled up till this particular level. Okay, after some time, after 2-3 seconds, it may get filled up till this level. Okay, after maybe 6-7 seconds, you can see that the water level, it is filled up till this level. After 10 seconds you can see that the water level is filled up till this level, and after maybe 20 seconds you can feel that, sorry, you can see that the water is filled up till this particular point. Okay, so see, as soon as the water is getting filled up till this point, so what you can say is that again we had added certain salt, okay, in this in the tank. So we had added certain salt, so we had also added salt in the tank, very in very few amount. Okay, salt plus H2O. Okay, so this anyhow this blue color indicates that this is my water and there is few amount of salt in it. Okay, so see what is going to happen. Now we, since we had added salt, so now this particular water will conduct electricity. Now this particular water, it is in that situation that it will, or it can conduct, or it should conduct electricity rather. Okay, it should conduct electricity. And now if you could see very clearly, just a second, let me take certain different color, maybe this one will do. So as you can see over here we are getting, or we had immersed, or we are inserted plus VCC. So over here as well at this particular point, as I told you, these are two wires. So this is wire 1, okay, this is, sorry, this is wire 2, this is wire 1. Let me just show it over here. This is wire 1, and now that this particular water has reached up till this level, so if you could see over here you are getting VCC, wire 1 is getting plus VCC, okay, plus VCC. And if you could see very clearly, since we had added salt in this particular water, so this particular water will conduct electricity, and therefore over here these two wires will act as if it is short circuited, and over here at wire 2 as well you will get plus VCC. Okay, and now these two particular points, if you could see very clearly, let me take certain different color, maybe this one will do. See, this one and this one, so these 2 points will act as if it is short circuited. So see, this point and this point, and this point will act as if it is short circuited. Why? Because the potential difference across these 2 points, it is same, and that is nothing but VCC. Again I'm repeating this particular point because this is a kind of heart of our project, okay, or this is a logic of our project, logic 1 you can say, because in future you will see that we have developed a number of logic. So this is most important thing that we should know. Okay, and that's why this particular project, it won't be that efficient because of this reason. Why? Because we are adding salt. Again I will repeat, let me just go back. So see, the pH of normal water or distilled water, it is 7, right? Current does not flow through the pure water, that is if the water has pH of 7. So by adding certain impurities, let's assume that impurity is salt, we can change the pH of water, and then this water will conduct electricity or current through it. So okay, so this was our basic understanding. So what we assume, so this was our case 1, wherein what we are doing is that the tab is closed and therefore the water won't flow, right? Now since the water is not flowing, okay, so this will act as an open circuit. Why? Because both of these terminals, okay, both of the wires, they are not getting any potential, okay, and even though we are immersing this VCC in the tank, but how come this particular VCC will be getting connected in will be getting connected with this particular wire? Because there isn't any such path in between. If you could see very clearly, there isn't any such path in between to connect these 2 points as well, right? So that's why these 2 wire will act as if it is open circuited, right? So there won't be any current flowing through this particular wire. Great. Now in case 2, what we saw is that, let's assume the tap is open. Okay, the tap is open, therefore the water will flow. And now since the water is flowing, so maybe for first 5 seconds you will see that the level of water, it has reached up till this point. After 5 seconds the water is filled up to this point. After 15 seconds the water is filled at this point. After 20 seconds the water is filled at this point, and maybe at 25 or 30 seconds the water is getting filled up till this level. And the moment it gets filled till this point, so what you can say is that, see, since we had immersed VCC and we had added salt in this particular water. Okay, but make sure whenever you are adding salt in this water, stir that water, okay, so that it should get mixed with the water appropriately. Okay, and in which case we'll come to the point. Okay, so now that we had immersed VCC and these two wires, okay, so this VCC, so that means plus VCC. If you see at this particular point, you will also get plus VCC over here if you want to check with the help of multimeter. So the potential of this water, whole water, is plus VCC. That means what? These two wires will act as if it is short circuited. Okay, these two wires will act as if it is short circuited. Why? Because now the potential of the water, or the voltage of the water, is plus VCC with respect to ground. Okay, I hope you understood this particular thing. Great. And now, since we had done the sensing element, so let me just uh, uh, do the tick mark over here. So we had finished the sensing element. How exactly we had designed? We had designed the sensing element by taking two wires, adding salt and stirring the salt, okay, in the water, and then just by putting these particular plus VCC, or the positive and the positive terminal of the battery. Great. So till we had covered the sensing part. Now we will move to the controlling block. Okay.